Wednesday, and then we have our test on Thursday. Okie dokie smokies, here we go. Change this into degrees. Oh, please don't miss this one. You do it all the time. Pi is 180 divided by 5. You might not know what that is, so you may have to do the division. I'm confident. I believe you know how to do the division. So 180 divided by 5 is 36. Times 2 is 72 degrees. So there it is. That's all there is to it. You do that over and over and over again in other kinds of problems. Right? Got that one. Okay, now change this one into radians. What's our strategy when we have to change a degree into a radian? We set up our proportion. Pi over 180 equals x over 100. Pi over 180 never changes. X over whatever your angle is. So 180x equals 100 pi. X equals 100 pi over 180, and then please take the time to reduce that. Zeros cancel. 10 over 18 would be 5 pi over 9. Okay? Now we got an arc length problem. The directions say find the arc length. We know what x equals. This right here. What is the arc length? Okay, so what's our formula for that? How do we find arc length? Radius
Plus or times
radians. So radius times radians. So we are going to multiply two things together. The radius times the radian measure of the angle. Now the radius we know is 6. The angle is 125 degrees. So we're going to change that into radians doing what we just did. So pi over 180 equals x over 125 this time. So 180x equals 125 pi. And there's no zeros to cancel this time, but there are 5s. So 125 divided by 5 is 25. And I just did 180 divided by 5. It's 36. Now, is that the answer to the question,
No,
right?
no.
Circle 25 pi over 36. No. What did I do that for? To figure out what goes here. So we're going to put 25 pi over 36 up there. And then our answer is going to be 6 over 1 times 25 pi over 36.
That's it. We have to simplify.
Well, yes, you have to simplify it. Yeah, then you multiply straight across. But you might notice, will this cancel into this?
Yeah.
So your answer is just going to be 25 pi over 6.
That's if it cancels out.
Hmm?
That's if it cancels.
You always cancel. If it cancels, you always cancel. If you multiplied straight across, you would have to reduce that fraction. Yep. All right, two-step problem. Everybody got that? Radius times radians. Probably that's going to be a degree measure. It's been a degree on every practice test. So you're going to need to change it into radians. Doing just this process right here. And then multiply. Okay, then we got our multi-part problem here where you have to find everything. Zero your beady little eyes in on this. What does that tell you?
Where you're going to graph.
What quadrant, where you're going to graph it. So think about your labeling. Think about when you graph angles, when you draw a picture of angles. Think about your labeling. It's like this, right? So if we are between 270 and 360, aren't we in quadrant 4?
Yes.
You okay?
Yeah.
Okay. And what do we know about angles in quadrant 4? We know this will be positive and this will be positive.
Yes.
And why did I label adjacent and hypotenuse? Because they gave me cosine.
Yes.
And then what do I do every single time I know two sides of the triangle? Pythagorean Theorem to find the third. And when I do that, it's 2 squared plus x squared equals 3 squared, because the hypotenuse is always the one that's over here. I don't care about these two, order is irrelevant, but the hypotenuse has to be over here. So what does x end up being? Square root of 5?
Yes.
But make sure you mark it negative. Why is it negative? It's going down in quadrant 4. Y is negative. The vertical is negative. Now, once you have that, then you should be able to do all the memorization stuff you just did on your quiz and just start plugging them in. So what sign?
Opposite.
Negative root 5 over 3, because it is opposite. Here's your angle. It's opposite over hypotenuse. What's tangent? Negative root 5 over 2, because it is opposite over adjacent. And then we'll do the reciprocals. Cosecant is the reciprocal of sine. So negative 3 over root 5, negative 3 root 5 over 5. Secant, 3 halves. Actually, we could have done that one right away, right? Because we knew the cosine. And then cotangent, 2 over negative root 5, or negative 2 root 5 over 5. Anybody have a question about a step in that problem? Seems like we've been doing those forever. Alrighty? Okay, now we've got several questions. Remember, this is the no calculator page, right? So we're all clear on that. Okay, so I'm going to draw a picture of a triangle in quadrant 1. Somebody tell him, how did I know it's in quadrant 1?
It doesn't say different.
Yeah, it doesn't say different.
1 over 1.
And that, I'm thinking that is a fraction, 1 over 1. Now, I don't know what the angle is, but I know that its tangent, its opposite and adjacent is 1 over 1.
That'd be root 2.
Which tells me this has to be root 2, which tells me the angle must be 30. 45, yeah, the angle has to be 45, 1 root 2, and that's the answer to the question. Remember, kids, think about when you use that button on your calculator. When do you use that button on your calculator? When you're trying to figure out the angle? So when you see that, it means figure out the angle. We're just not doing it with our calculator, we're doing it by hand. But the angle is 45 degrees. Now this is exactly the same thing, only this one is going to be drawn in quadrant 2. Because I told you. And this time, the cosine is negative root 3 over 2. Does that make sense?
Yes.
which means this side has to be 1. Mrs. Ford, how do you know that? It's a 30, 60, 90 triangle, right? If you want to do the Pythagorean Theorem, you can, but it's going to come out to be 1. How big is this angle then?
60.
30. 30 is across
Oh,
from the
35.
1. That's a 30. But if you put 30 as the answer, I'm going to have to take off some points because the answer is actually this one. Your angles are measured up and around,
Yeah.
right?
That's my
30 would be in quadrant 1. You want to be in quadrant 2. So how big does that angle have to be? 150. And how do we know it's 150? 180 minus 30. Remember, we always use 180 or 360 depending on which side our angle is on. So 180 minus 30 is 150. That's the answer to the question, 150.
If it's in quadrant 1, we wouldn't do that. But
No, if it's in quadrant 1, it would just be 30.
okay.
All right, how about here? What do I do here? 180 divided by 2 is 90 times 3 is 270. Please do not stop there, boys and girls. That is not the answer. All that does is tell you what angle you're looking at. Where's 270?
On the
Oh, shoot, it's on a line, isn't it? 270 is on a line. So when my angle is on the line, what do I have to do? Draw a circle. So here's my circle, here's my angle. 270 is straight down. What angles are we going to draw circles for? 0, 90, 180, 270, 360, right? Those are the ones we're drawing circles for. Now we know when we draw that circle that we're using a radius of 1. Tell me about this point then. Here's the origin, I'm coming straight down.
0, -1.
So that's going to be 0, -1. We're coming straight down. So x is 0, y is -1. From the point, I want tangent. Again, your memorization. What's tangent?
Well, -1 over x.
Y over x,
Yeah.
which for us would be -1 over 0, which is undefined. Okay, there's a couple more like that. Sine 5 pi over 6. Cosine 7 pi over 4. And cosecant 7 pi over 6. Alrighty. What do we do first here? Next problem is sine 5 pi over 6. So what do I need to do? 180 divided by 6 is 30, times 5 is 150. If you can't do that in your head, it's fine. Do it over to the side. Don't take wild guesses and get it wrong. This is the sine of 150. So what do I have to do now? What do I have to do now? Draw 150,
Yeah.
which is going to be over here.
The angle's 30.
So how big is the angle in the problem then?
30.
30. What math did I do to get 30? 180 minus 150. Right? 180 minus 150. Okay, so let's see. If that's 30, this is 1, 2, root 3. And if I could wish myself to be able to sit on your shoulder and whisper it in your ear while you take the test, it would be to remind you for the negatives, negatives, negatives. Remember, if you draw that triangle anywhere except quadrant 1, make sure you put in the negatives. So where are the negatives here?
Negative root
Just
3.
on the root 3. Now I want the sign. Sine is opposite over hypotenuse. So the negative didn't really matter this time, it's just 1/2. Everybody following along? All right, same thing. These problems are exactly the same. Pi divided by 4 is 45. And then 45 times 7 is 315. $315 is going to be all the way around to here, right? That's 315. What math are you going to do to find this angle? 360 minus 45, which is, or 360 minus 315, which is 45. Right, 360 minus 315. So my sides are 1, 1, root 2. This one is negative. Cosine adjacent over hypotenuse. Root 2 over 2. We all right with that, folks? All right, one more of those. Here we go. 7 pi over 6. That would be 210. Cosecant 210. Everybody good with that? Okay, where's 210? Here? How big's that? 60? 30. What math do I do? 210 minus 180. It's always 180, guys. So 210 minus 180 will be 30. If you said 60, stop it. Stop it. It's 210 minus 180. The sides then are 1, 2, root 3. What's negative this time?
1. Negative
Both of these, right? Cosecant. Hypotenuse over opposite. So hypotenuse over opposite would be 2 over negative 1, which is negative 2. Don't you dare have bored out of your minds, people. You have a test over this. Oh, okay. Where is the secant negative? Remember, less than 0 means negative, and the tangent is negative. Okay, so let's just pause for a second. What's secant?
Opposite of cosine.
It's a reciprocal of cosine, so it would be r over x, right? And what's tangent? Y over x. All right, so let's think about this for a minute. I want secant to be negative. Secant is this fraction. Will r ever be negative? No. So the only way that secant can be negative is if x is negative. So you're telling me that x must be negative. right? That's what you're telling me. All right, now, come over here. Tangent is y over x. You have already told me that x is negative. Tell me about y then. If this fraction has to be negative, but x is already negative, what about y? It's positive, right? So now you've told me that y is positive. Where does it happen in the coordinate plane that x is negative, but y is positive? Second quadrant. It happens right here. That's where x is negative, but y is positive. Okay. Now we're going to sketch. Here we go. This is it for the no calculator part, then we'll get out our calculators. All right, so when you do this on your test Thursday, please, please, please start by drawing the shape. So this is a positive sine curve. So we start at the origin and go up and down. So we got the shape, right? Everybody knows the shape. Now, what about these labels? Look at your equation. Those have to do with the amplitude. What is the amplitude in this equation? 2, well, the labels are 2 and negative 2. So the amplitude is 2. Now you need to label your x-axis at the high point, the crossing point, the low point, and the end. Those would have been normally 90, 180, 270, and 360. But what happened in this equation? We divided them by a third. Right? So 90 divided by a third is 90 times 3 over 1. So this label is 270. And then you can do the same with all of those, or you can just add 270. So 540, 810, 1080. Whatever is easiest for you. I just added 270, but you could also do this multiplication. That would work too. Which makes the period of this function then 1080 degrees. Now we've got a tangent. Tangents, remember, are just asymptote, asymptote, squiggly line through the origin. What is the amplitude for a tangent? There isn't one. Please don't miss that. Now, the period has to do with where the asymptotes are. The period's how far apart the asymptotes are. Well, normally they're from negative 90 to 90. That would be the normal situation. But what's happened up here? They've been divided by 2. So your labels are negative 45 to 45, which makes them how far apart? 90. So your period is 90 degrees. Everybody still hanging with me here? All right. Oh, now watch this one carefully. It's a cosine, but there's a negative out in front. So when I draw it, I'm going to start down here. Remember that your cosine ends where it starts. So it started down here, so it ends down here. That's the shape, right? What's my amplitude? 1/2, so I'll put negative 1/2 and 1/2 on here. Now my labels need to be where I cross, where I peak, where I cross, and where I end. And normally, just like the sine, they'd be at 90, 180, 270, 360. But what have I done? Divided by 2. So my labels are 45, 90, 135, and 180, which makes my period 180 degrees. Any issues with that? Okay, so on Thursday then, you'll turn this page in, and then I'll give you another page, and you'll go back and sit down and get out your calculator. And we'll do all the calculator problems now. So degrees, minutes, seconds, 128.735. So there's no work to show here. This is just, you're going to type it in. In fact, there's no work to show for the next part either. This is all, you just type it in. So you either know how to do it or you don't. So for this one, to get degrees, minutes, seconds, do you remember what you do? We type in the decimal. Just type it in. And then what? Second apps down to DMS. And I hope you got 128 degrees, 44 minutes, and 6 seconds. Okay. Okay, now here we go. Be careful, because the only time really that you can mess this up is if you're in the wrong mode. So right now my calculator's set in degrees, so I am going to do this problem because it has a degree mark. I'm going to do this one, and I'm going to do this one. All of those because they all have degree marks. So I'm going to type it in. How do I type in a cotangent? 1 divided by tangent. That's right. Negative 0.8693. We're rounding to the nearest 4 decimal places. So negative 0.8693. One more time. How do we type in a cotangent? 1 divided by tangent. Now I need to type this in, so I got to remember how to get all those things. So sine 52. Remember how to get your degree mark. 11. Remember how to get your minute mark. And your second mark. Did you get 0.7900?
Yes.
If you did not get 0.790, I want you to lean over to your neighbor right now and get that sorted out. Right now, you got 10 seconds. Get it sorted out with your neighbor. And then same thing, only we don't have the seconds. So tangent 153, 17. Negative 0.5033. Is that okay with everyone? So then what do we do? So now we're going to switch the mode over to radians. And then we can do these other three, right? So we're just going to type in the buttons. So second sine, whoa, I don't know what that was. Second sine 0.514. Did you get 0.5398? Now when you type this one in, make sure you're using the pi button. You're going to type tangent 18 pi divided by 17, actually using the pi button, which is second caret, right under your clear. Did you get 0.1869? And cosine 1.3, 0.2675. There's no partial credit for these, so make sure you're typing them in correctly. Everybody good? All right, so then we're moving on to the next part, which is finding parts of triangles. And I do want you to pay attention in the picture. Do you see how the angles are marked in degrees? So what does that mean? Change it back to degrees. The only time your calculator should be set in radians on this test is going to be when you're doing those few problems right there that we just finished. Every other problem on the test, the word problems, everything are in degrees. So make sure that you change it back after you have done that one section. Are you listening to me? Did you hear what I just said?
Yes.
Okay. Because I'd hate for you to miss everything that came after that. That would be really bad. All right, so here we go. We're going to work on this triangle right here. See that angle? Which side is this? Opposite. Which side is this? That right there, kids. If you think that way, you know exactly what your equation is going to look like. Because if you have a opposite and hypotenuse, then you know what? It's sine. So you're going to say sine 37 equals opposite over hypotenuse. No confusion. Can't be any confusion. It's opposite and hypotenuse. That's sine. Now to solve that, we got to get x by itself, so we'll move the 12 over. We'll make sure our calculator's set in degrees. And 12 sine 37, I got 7.22. Doesn't tell me how to round, so I'll just do the 100, 7.22. Okay? Jacob? Wake up. Okay, now what? So pay attention Okay, which side is this? Opposite. Which side is this? So one more time, we're going to use sine. So sine angle, so sine x equals opposite over hypotenuse. Uh-oh. Please don't bring the 19 over. That won't do you any good. The only way to solve that is to do what? Second sine. When x is the angle, we have to do second something. So second sine, 18 divided by 19. Did you get 71.33 degrees?
Mm-hmm.
Everybody got it? So when you see these pictures, label whatever side you got. So opposite, adjacent, hypotenuse. Label them so that you will know what function to use. You're either going to use sine, cosine, or tangent, and that's going to depend totally on the angle or the sides that you have in the problem. All right, now we have to draw a course at 204 degrees. So that picture is going to be there for you, but I'm not going to have any angles on it. So you need to remember that on the compass, where is the 0?
North.
On the compass, where is the 0?
North.
Straight up. On the compass, that's 0. In regular trigonometry, this is 0, and it goes this way. But on the compass, that's 0, and it goes this way. I can't help it. It's the way it is. So 204, right? Yeah, 204 is going to be right here. And you're going to draw that vector, and you're going to draw 204 degrees starting due north and coming around just like that. That's 204 degrees. And that's all you have to do. Now the next question, we're going to type this in on our calculator. When you type that in on your calculator, just type it in. So tan second cosine 2 divided by 5, and it's decimally, it's 2.2913.
Yeah.
Now to do it exactly, I have to draw a picture. And I draw, this is a two-part problem. You can kind of tell that because it's got a tangent and a cosine in it. So start with the parentheses and draw a picture of it. So you want to draw a picture of an angle that has a cosine of 2/5. Did I put the 2 and the 5 in the right spot? How did I know to put them there? Adjacent over hypotenuse. Now what do I always do when I have two sides? Pythagorean Theorem. That's the hypotenuse. So 2 squared plus x squared equals 5 squared. What'd you come up with for your other side? Root 21. Now, that's a picture of the parentheses. Beautiful. Tell me what is the tangent in that picture? Root 21 over 2. And if you have time and are interested in checking your answer, what should happen if you typed in root 21 divided by 2? You should get this decimal, right? So you can kind of check to make sure you're on the right track. test does not quite have this many word problems on it. We'll do as many as we can here. So here we go, question A. What do we have? We have our squirrel on the top of the tree. And he's doing what he's always doing, looking at a nut on the ground. The tree is 64.5 feet tall, right? And the angle of depression is 27. Find the distance from the squirrel to the nut. Where does the X go?
Hypotenuse.
There's the squirrel, there's the nut. That's their distance apart. What equation do we have? Sine 27 equals opposite over hypotenuse. When you solve this, bring the X over. And then you're going to divide. So 64.5 divided by sine 27. I got 142.37. And that would be feet. Anyone have a question there? Well, instead of a seagull looking at a fish, we have a pelican spotting a crab. So we have the pelican on top of the lighthouse, and he sees a crab down here in the water. The pelican is 93 feet above sea level. The pelican is 202 feet from the crab.
That's the
The pelican is 202 feet from the crab. Isn't that the hypotenuse? Because there's the pelican and there's the crab. Right? And I want to know the angle of depression. Sine again. Sine x equals opposite over hypotenuse. What buttons do I have to press to solve that? Second sine. Remember, if you are looking for an angle, you must do the second thing. So second sine, 93 divided by 202. I got 27.41 degrees. Airplane, airport. The airplane is 4,500 feet above the ground. The angle of depression is 16.3 degrees. How far is the airport from the point on the ground directly beneath the plane? So X is going to go here. It's a point on the ground.
Opposite over adjacent. Tangent.
Tangent. Tangent 16.3 equals opposite over adjacent. So X tangent 16.3 equals 4,500. And you will type in 4,500 divided by tangent 16.3. 4,500 divided by tangent 16.3. Did you get 15,388.80 feet? Right? All right, let's set up number D. 70. We may not get a chance to work them out, but let's at least get them set up. So what's D look like? Find the length of a shadow of a 19-foot flagpole when the angle of elevation is 59. Find the length of the shadow.
It'd be like
It'd be the bottom. Shadows are on the ground. What equation will you write? Tangent 59 equals 19 over x. And then we will solve. Okay, and the last one. What is the angle of elevation of a Precal student looking at the top of a building that is 51 feet tall if he is standing 200 feet from the building? Where does the 200 go? The guy is standing 200 feet from the building. It goes on the bottom. So this will be another tangent problem. And since I'm looking for the angle, what am I going to type in? What am I typing in? Second tangent, 51 over 200, and that will give me the answer to the question. Okay, so if you extended time, you filled the thing out, everybody remembers that it's math, please.